Good day, viewers. Today we're gonna discuss about the California Bearing Ratio Test or the CBR test. Just wanna give credits to Mr. Sai Krishna of Tricona Conskill for having this lecture. Okay, so let's start. So the California bearing ratio, it is the ratio of force per unit area required to penetrate a soil mass with a standard circular piston at a rate of 1.25 millimeter per minute to the required for the corresponding penetration of a standard materials. This formula is used, so CBR is equal to test load over standard load times 100. So we can see the table below. So the test may be performed on an undisturbed specimen. So for the objective, to determine the California bearing ratio by conducting a load penetration test in the laboratory. So for the need and scope, the California bearing ratio test is penetration test meant for the evaluation of subgrade strength of roads and pavements. The result obtained by this test are used with empirical curves to determine the thickness of pavement and its component layers. This is the most widely used method for the design of flexible pavement. So for the equipment and tools, first is the cylindrical mold. Next is a spacer disc. Next is a surcharge weights and slotted weights. Another equipment is the penetration plunger and the loading machine. Also, we have other miscellaneous apparatus to be used on the CBR test. So for the preparation of the test specimen, for undisturbed specimen, we need to attach the cutting edge to the mold and push it gently into the ground. Remove the soil from the outside of the mold which is pushed in. When the mold is full of soil, remove it from weighing the soil with the mold or by any field method near the spot. Determine the density. For a remolded specimen, prepare the remolded specimen at Proctor's maximum dry density or any other density at which the CBR is required. Maintain the specimen at optimum moisture content or the field moisture as required. The material used should pass the 20 mm sieve, but it should be retained on a 4.75 sieve. We have to prepare the specimen. First is the dynamic compaction. So take about 4.5 to 5.5 kg of soil and mix thoroughly with the required water. Fix the extension collar and the base plate to the mold. Insert the spacer disc over the base and place the filter paper on the top of the spacer disc. Compact the mixed soil in the mold using either light compaction or heavy compaction. For light compaction, compact the soil in 3 equal layers, each layers being given 55 blows by 2.6 kg rammer. For heavy compaction, compact the soil in 5 layers, 56 blows to each layers by 4.89 kg rammer. Remove the collar and trim off soil. Turn the mold upside down and remove the base plate and the displaced disc. Weigh the mold with compacted soil and determine the bulk density and dry density. Put filter paper on the top of the compacted soil and clamp the perforated base plate onto it. So for the static compaction, calculate the weight of the wet soil at the required water content to give the desired density when occupying the standard specimen volume in the mold from the expression W is equal to the desired dry density times 1 plus W times V, where W is the weight of the wet soil and the small w is the desired water content, and V is the volume of the specimen in the mold as per mold available in the laboratory. Take the weight calculated as above of the mixed soil and place it in the mold. Place a filter paper and the displacer disc on the top of the soil. Keep the mold assembly in static loading frame and compact by pressing the displacer disc till the level of the disc reaches the top of the mold. Keep the load for some time and then release the load. Remove the displacer disc. The test may be conducted for both soaked as well as unsoaked conditions. If the sample is to be soaked in both cases of compaction, put a filter paper on the top of the soil and place the adjustable stem and perforated plate on the top of filter paper. Put annular weight to produce a surcharge equal to the weight of the base of the material and pavement expected in actual construction. Each 2.5 kg weight is equivalent to 7 cm construction. A minimum weight should be put. Immerse the mold assembly and weight in a tank of water and soak it for 96 hours. Remove the mold from the tank. Note the consolidation of the specimen. Place the mold assembly with the surcharge weights on the penetration test machine. Sit the penetration piston at the center of the specimen with the smallest possible load, but in no case in excess of 4 kg, so that the full contact of the piston and the sample is established. Set the stress and strain dial gauge to read 0. Apply the load on the piston so that the penetration rate is about 1.25 mm per minute. Record the load readings at penetrations of 0.5 to 12.5 mm. Note that the maximum load and corresponding penetration if it occurs for a penetration less than 12.5 mm. Detach the mold from the loading equipment and take about 20 to 50 grams of soil from the top 3 cm layer and determine the moisture content. For the observation and recording, for dynamic compaction, we have to consider this table. So for penetration test, calibration factor of the probing ring for 1 div is equal to 1.176 kg. Surcharge weight used for 2.6 kg per 6 cm construction. Water content after penetration test. Least count of penetration dial is 0.01 mm. So we have to record the data on this format. And for the interpretation and recording, you have to compute the CBR using this formula. The CBR values are usually calculated for penetration of 2.5 and 5 mm. Generally, the CBR value of 2.5 will be greater than 5 mm. In such a case, the formula should be taken as SBR for design purpose. If CBR for 5 mm exists for 2.5 mm, the test should be repeated. So thank you. That's the end of our discussion.